Hello everyone, welcome to the first video in this series. We start with problem number 1. Consider a vector given by this. The surface integral of this vector over the surface of a cube of side A and centered at the origin is. So this vector looks very similar because the electric field has the form 1 by 4 pi epsilon 0 q by r square and r cap. So if you take the charge to be 4 pi epsilon 0, the electric field is then r by r square, and this is exactly V. So we need to find the flux. The flux can be found using the Gauss law. E dot ds and integral over the closed surface is equal to 1 by epsilon 0 times the charge inside. So this is 1 by epsilon 0 times 4 pi epsilon 0 and equal to 4 pi. Option D is the correct answer. Problem number 2. If a force F is derivable from a potential function V of r, where r is the distance from the origin of the coordinate system, it follows that. So we have F is equal to gradient of V, and we know that curl of a gradient is 0. So thus curl of F should be 0. So option A is the correct answer. Problem number 3. A book contains 600 typographic errors in its 600 pages. These typo errors occur completely at random. Using the Poisson distribution, the probability that a page contains no error is. So a page contains X error is given by this distribution. It is lambda to the power x e to the power minus lambda divided by x factorial, and lambda is the mean. In this case, this is 600 divided by 600 equal to 1. The page contains 0 error would be p of x equal to 0, and that is e to the power minus 1. So numerically it is 0.37. So option C is the correct answer. Problem 4. For which of the following values of z will the function w given by this, defined by z equal to this, ceases to be analytic? So we have z equal to sine u cos hyperbolic v plus I cos u sine hyperbolic v. So this cos hyperbolic v we can write as cos of I of v, and this sine hyperbolic v can be written as I sine of I v. So we can use the sine rule to write it as sine u plus I v, and this is equal to sine of w. Now we have to invert this. Z is equal to sine of w, which is equal to e to the power I w minus e to the power minus I w divided by 2I. Take u to be e to the power I w, and this is equal to 2I z is equal to u minus 1 by u, or u squared minus 2izu minus 1 is equal to 0. We solve it for u. U is minus b, in this case 2iz, plus minus b squared, that is 4z square plus 1 divided by 2, and this is equal to iz plus minus 1 minus z square. So this is e to the power iw. So w is given by minus I log of iz plus minus square root of 1 minus z square. The function w ceases to be analytic when z equal to plus minus 1 due to the branch cuts of this log function. So option D is the correct answer.